All right, here we go. Equations for growth, decay, for exponential growth and decay. And these really are, to be honest, the same equation. Just whether it's growing, it's going to be a positive, so plus r. And if it's decaying, if it's shrinking and going away, then it's going to be minus that rate. And so as we go into this, I want to talk about something that you probably already understand, but let's take the number of 300. If I have 300 and it grows by 15%, 15%, so times 0.15, 15 as a percent, it's going to grow by 45. So our 300 has grown by 45, so 300 plus 45 gives us 345. Now, rather than doing it as finding out how much is growing and then adding that into the original amount, the reason we've got 1 plus r being our rate of growth, is because we can do it all at the same time. And what's going on here is 300 times, well, 115%, because 100%, that 1 is the original amount, plus the rate that I remember we had the 15% of this was going to be 45, and then 300 plus the additional 45 gave us 345. Notice we can multiply it by 1.15, so that 100% plus the 15% that it's being grown by gives us the 345. So we can just jump there, and that's what's going on inside here. And same thing with the minus. If I had 300 and it lost 5% or 15%, so 300 minus the 45 people, it'd be at 255. But notice how, again, we can do that right here by multiplying 300 by, well, if it's 100% minus 15%, that's times 85%. And we again get right to 255. So just notice that you can jump right to that. And that's what's going on inside the parentheses here. Now with exponential growth and decay, that same thing is happening repeated times. And so we're going to have a number of times as the exponent, how many times we'll need to either take the growth or take the decay. So A of t is going to be the amount in terms of time. So the function a of t, and that is our final amount. How much something is growing or decaying, and what at the end of all that, what's happened. So again, this is for growth, and this one is for decay. Though really they are the same equation. All right, so a of t is our final amount. A sub naught, or a sub 0, if the 0 doesn't mathematically affect it, it's just specifying what amount it is, and it's amount when the 0 there is for when time is 0. So this is the initial amount. Before time has started passing in the problem, what is it at the very beginning? So a sub naught or a sub 0, either way is fine to refer to that. So sorry, I'm writing initial amount. So we're going to plug in our initial amount, multiply it by the, essentially by the 100% by itself, plus the rate. And so rate being how much it's growing. So R stands for rate. And that is in percentage form, or decimal form, not in percentage form. You're going to take that percent increase and write it as a decimal. So again, decimal form. And then t is time. How many times we are going to be taking the percentage of growth. So let's, yeah, again, for it's the same equation over here, so I'm not going to fill those in. But if it's growth, we're adding. If it's decaying, we're subtracting, and we'll go from there. All right, hope that helps.